let's take a look at Chapter 9. Excel really doesn't do Chapter 9, so I've come up with a spreadsheet to do it. And the main thing that the spreadsheet does is your confidence intervals. And we'll use this flowchart. Where you can find a confidence interval of a mean. And then there's the first case where sigma is known. Now sigma is your population standard deviation. And then the second one is where sigma is not known. And then we can find the confidence interval of a proportion. And the confidence interval of the standard deviation, or it could be variance. Okay. There it is. In this spreadsheet, top part of the confidence intervals, and you see how it says it's broke down. Confidence interval about a population mean, sigma is known. Confidence interval about a population mean, sigma unknown. Confidence interval about a population proportion. And then this one is where confidence interval about a population standard deviation and about a population variance. So basically just plug in your numbers in the little yellow boxes here and it calculates for you. Hard part is, not that it's that hard, but the hard part is determining which one to use. So let's look at some examples of that. A researcher wishes to estimate the proportion of adults in the city of Derby who are vegetarian. In a random sample of 770 adults from the city, the number that are vegetarian is 200. Find a 95% confidence interval for the proportion. Confidence interval for proportion, there's no choice. It's going to be, from our spreadsheet, this one right here, confidence interval about a population proportion. So let's see what they're giving us. N is 770. Actually, we want X first. 200. Now that'll always be your smaller number, which is 200, and N will be the 770, your larger number. 95% confidence interval. So if I put in 95 there, then our answer is this right here. So we're 95% confident. True value falls somewhere between 0.23 and 0.29%. Okay, 43 packages are randomly selected from packages received by a parcel service. That's N. The sample has a mean weight of 29.8. Since that's talking about our 43, that would be X bar. Assume that this little O with a flip equals 3.9 pounds. Well, this symbol right here is sigma. So they're giving us sigma. What is the 95% confidence interval for the true mean? So confidence interval for the mean, sigma is known. That's what drives us to use this one right here. Sigma is known for population mean. So sample mean was 29.8. Population standard deviation was 3.9. Oops. N was 43. And the 95% confidence interval, so put 95 in there. And our answer is this right here. Now when you do the homework and tests, I just say this is another name and just turn in the whole spreadsheet. You don't need to separate it, don't need to redo it. Just type in your parameters and plug it in. Okay, problem 3. 30 randomly selected students took the calculus final. The sample mean was 83 and the standard deviation was 14.1. Now, sample mean was 83. It's talking about the 30. 30 is our n, so x bar will be 83, and the standard deviation was 14.1. Well, this 14.1 is referring to those 30 students, so this would be S, sample standard deviation. Construct a 98% confidence interval for the mean. Confidence interval for the mean, sigma is not known. Confidence interval about the mean, sigma is unknown. This one. So, let's see. Sample mean was 83. Sample standard deviation was 14.1. N was 30. And 99% confidence interval. So put in 99 there. And our answer is right here. Now, if you're real curious on how I did this and everything, you can click up in these boxes here, and you can kind of figure out what I'm doing if you're halfway decent with formulas in Excel. Well, I shouldn't say halfway decent. If you're pretty good with formulas in Excel, it's not that easy, which is why we don't cover it in this class, because we're not requiring like an in-depth knowledge of Excel. With the book actually comes their own package that they wrote to do the same thing, but then that'd require everybody to have the book, so I came up with my own spreadsheet. And last one. Assume the heights of female executives are normally distributed. A random sample of 20, so that's n. Have a mean height of 62.5, so that would be x bar, because this is referring to the 20. And a standard deviation of 3.7. So that'd be s, because it's referring to the 20. Construct a 98% confidence interval with population variance. Well, for a flowchart, confidence interval, standard deviation variance, there's no choice. Use one of these bottom ones here. And we're talking about variance, so I'll plug it in here. Sample standard deviation. Sample standard deviation of 3.7. N was 20. And percentage was 98%. And that'll give us our answer right there. Now, if you're given raw data, I won't give that to you in this class, but if you're given raw data, you're using this in another class's spreadsheet, instead of putting in the actual number here, what you can do is you can put equals standard deviation and then your range of numbers. Like maybe over in sheet 2, maybe I had my numbers right here. And then you'd do that. Of course, I don't have anything over there, but you can actually put a formula in here. You don't have to hard code the values. So don't think this is limited to just summary statistics. It can be done with raw data also.